Hi everyone! So today we're going to talk about section 3.9, derivatives of inverse trig functions. So let's recall what are the derivative formulas we have learned. We learned product rule, quotient rule, chain rule, and we learned trig limits and the derivative of trig functions, exponential function, logarithmic function, implicit differentiation, the logarithmic differentiation. And so today we're going to talk about the derivatives of inverse trig functions. So the idea is very similar how we derive the derivative of the log function. Okay, so first of all, let's recall what are the inverse functions. So arcsine of x is the inverse function of sine x. Do you still remember the picture of sine x? So let's draw here. So sine x pass through 0, and it looks like that, right? This is 0, and then this is pi, this is 2 pi, so it's 2 pi periodic, okay? And at pi over 2 is 1, so this is the graph of sine x. How do we get arcsine of x? We know for inverse function, what's the property is their mirror image across the line y equals x, right? So let's say if y equals x is here, okay, and in order to have an inverse function, we require the function has to be 1-to-1. So sine x is not 1-to-1. That's why we restrict to a 1-to-1 piece. So this piece is 1-to-1, okay, and then we flip it over the line y equals x. So that's why we get this picture, okay. So we can see here at this point, this is pi over 2, and this is 1, it corresponds to this point. And at this point, x is minus 1, y is minus pi over 2, it corresponds to this point. Okay? Alright, and you can see the domain and range actually flip. Okay, we know for sine x, the range is minus 1 to 1. That's why for arcsine of x, the domain is minus 1 and 1. Okay, so how do we get the derivatives? Okay, so this is how we derive the derivative. We use the implicit differentiation. Okay, so first of all, let's make it bigger. Okay, so first of all, we have y equals to arcsine of x. Alright, then what's x? Well then, x equals to sine of y, right? And then we can do implicit differentiation. Derivative of sine y is cosine y, and when you finish differentiating the y, you have to multiply by y prime, and the derivative of x is 1. Okay, how do we solve for y prime? Well, y prime is then 1 over cosine y. But what is cosine? Do you still remember the trig identities? If you don't, it's okay. Let's draw it here. Okay, so we have the hexagon like sine x, cosine x, tan x, 1, cotangent x, secant x, cosecant x, right? And there are 3 diagonals, okay? And we know on the diagonals, the product of the two ends is the middle one. So sine x times cosecant x is 1. Secant x times cosine x is 1. Tangent x times cotangent x is 1. And there are 3 upside down triangles. Right, this one, and this one. And then the sum of the square of the upper 2 corners is the bottom square. So that's why this triangle, we have sine square plus cosine square equals to 1. This triangle, we have tangent square plus 1 is secant square. In this triangle, we have 1 plus cotangent square is cosecant square. Okay, so now what is cosine of y? Well, we know now cosine square is 1 minus sine square, so that's why here we have 1 over square root of 1 minus sine y square. And what is sine y? Sine y is x. Well, that's why y prime is 1 over square root of 1 minus x squared. So that is the derivative of the arc sine. Okay, so the way how to find the derivative of arc cosine are very similar, and you can see the derivative of arc cosine is just you have an extra negative in front of it. Okay, and let's look at the picture. All right, what's the picture of cosine? Okay, so the picture of cosine is this. So in order to have an inverse function, we pick the 1-to-1 piece, right? 1-to-1 piece. Actually, we pick this piece. So this is 0, this is pi, at 0 is 1, at pi is minus 1. So that's why when we flip it over the line y equals x, this point get flipped to this point. And then this point get flipped to this point. Okay? Alright. Next, let's look at the tangent. Okay, what's the graph of tangent? Oops, I used green, so let's have green again. Okay, so what's the graph of tangent? So this is the graph of tangent. We know it's pi periodic. Okay, but in order to find the inverse function, we only restrict to a 1-to-1 piece. Okay, so which means we only restrict to this guy. Okay, so when we flip it over the line y equals x, oops, my line is not so good. Okay, anyway, so when we flip it over, this is what we get. Okay, and you can see now the domain is all real numbers. The range is from minus power 2 to power 2. Okay, how do we find the derivative of arctangent? Well, the way how we find it is very similar. Okay, so first of all, we let y be arctangent of x, and then so x is then tangent of y. Okay, and then we do implicit differentiation. What is the derivative of tangent? So I hope that you have remembered all the formulas of the trig derivatives. Okay, so the derivative of tangent is secant square. Secant square, and then times y prime. Derivative of x is 1. Okay, so y prime is 1 over secant square. And what is secant? Okay, if you go back here, look at our picture. Secant square is actually 1 plus tangent square. Okay, so that's why here that equals to 1 over square root of 1 plus tangent square. What is tangent? Oh, sorry. You see, this is secant square, so we don't need square roots. Okay, so that's why 1 over, and tangent of y is x. So that's why the derivative is 1 over 1 plus x squared. And the way how we, oops. Oh, move it here, okay. The way how we find the derivative of arctangent is very similar, okay? And you can see the derivative of arctangent is just minus of whatever we have for the derivative of arctangent. Okay. Next, All right, so secant, do you know the graph of secant? Well, when I draw the graph of secant first, I don't remember the graph of secant, but I do remember the graph of cosine, right? And you know what's the relationship between secant and cosine? Yeah, secant is 1 over cosine. So secant 1 over 1 is 1. 1 over like 0 minus is minus infinity. 1 over 0 plus is infinity. So that's why the picture is like this. So whenever you have 0 for the cosine, you actually get a vertical asymptote for the secant. So in order to have an inverse function, we have to restrict the function into a 1-to-1 piece. Okay, so we restrict it to the 1-to-1 piece. So here, the piece we choose is from 0 to pi. So pi is here. So this is the piece we choose. And then when we flip it over the line y equals x, this is the graph we get. Okay? All right. So how do we get the formula of the derivative of secant? Okay, similar, we first let y be secant of x, then x is secant of y. When we do implicit differentiation, derivative of secant is secant tangent times y prime. Derivative of x is 1. So y prime is then 1 over secant y times tangent y. Okay? What is secant y? Oh, secant y is x. But what is tangent? Well, tangent, if you can remember, is actually secant squared minus 1. So that's secant y squared minus 1. And what's secant y again? Secant y is x. So that's why this is the derivative of that. Okay? And the derivative of cosecant is very similar. And we just have a minus sign in front of it. So as long as you can remember the derivative of sine, tangent, and secant, then the derivative of cosine, cotangent, and cosecant is just negative of the corresponding one. Okay? All right. So important. Do not confuse the inverse trig function with 1 over sine x, 1 over cosine x. They are very, very different, okay? All right, so let's work on examples. Okay, let me get my black. Okay, all right, so let's look at this one. When we differentiate, we look at the formats of the function. So this guy is like what? Something times something. So that is product, right? So we use product rule. What is the product rule again? Is the derivative of the first guy times second guy plus first guy times the derivative of the second guy. Okay, and let's continue. Oh, what is this? The derivative of ln of, you see this is a composite function, so we call it u. The derivative of ln of u is 1 over u, so we put the u here times u prime. And then here we just copy it. Okay, and what is the derivative of arctangent? U. You see this is not x, then it's like a chain rule. Okay, we let the inner function be u. The derivative of arctangent, okay, try to memorize Memorize that. So that is 1 plus u squared. U is 1 minus 2x squared times u prime. Okay? And now let's continue. Okay, what is the derivative of 2x cubed? 3 times 2 is 6. So 6x squared. And then we have 2x cubed plus 5 at the bottom. We have the arctangent 1 minus 2x. And then we have ln of 2x cubed plus 5. Okay, what is the derivative of 1 minus 2x? Yes, negative 2. So we have 1 plus 1 minus 2x squared. Okay, and that's it. You don't need to simplify. That's good. Okay? So don't forget, if you have any questions, you can always print screen and then ask me later. Okay? Alright, let's look at this one. What is the format? It's like 2 to the something, so exponential function, right? And we have a composite function, so this is like onion, so this is u, right? What is the derivative of 2 to the u? Do you remember the formula? What's the derivative of b to the x? Father looks like the son, but father has the mustache, and here we have a fancy mustache, ln of b, right? So in this case, what is b? Yes, b is 2. So f prime of x is 2 to the u. To the u times ln of 2. Okay, this is the regular derivative. Times u prime. Okay, remember each step we only do one thing. Okay, let's continue. So here we just copy it. Okay, and here, arcsine of something, right? So chain rule again with my new u is x squared minus 7. Derivative of arcsine is, do you still remember? 1 over square root of 1 minus u squared. So the u is this guy, squared, times u prime. Okay, everybody? Yes, 1 over square root of 1 minus u squared times u prime. Almost there, so we continue. Ln of 2. What is the derivative of x squared minus 7? Yes, that is 2x. And then we have the square root, 1 minus x squared minus 7 squared. Okay? Questions. Can we cancel the 2 and this 2 or this 2? No, don't cancel it, okay? You can combine this 2 and this 2 together, but you get plus 1 here. But I suggest you just leave it like that. Okay, you don't need to simplify, just leave it like that. Okay, all right, let's go to the next one. Okay, so what is the format of this function? Something over something, right? So it is quotient. So we use quotient rule. Do you remember quotient rule? That is the let's get more space. Do we have enough space? Yeah. Okay, let's make it bigger. Okay, is the derivative of the first guy. So the first guy derivative times the second guy minus the first guy times the second guy derivative. How about the denominator? We have the denominator square, right? Okay, let's continue. Okay, so what is this guy? Well, it's square root of something, so we are using chain rule, right? So chain rule with our u. Oops. Okay. Okay, with our u is this guy. This is our u. Alright. So then this is like u. Okay, I don't want to draw. Okay, yes. Alright, so here we have u to the 1/2. What is the derivative of u to the 1/2? That's 1/2. And then u to the negative 1/2 times u prime. Yeah, it looks complicated because it is actually we apply chain rule again and again. Okay, but here this is like u to the 1/2, derivative of that is 1/2 u to the minus 1/2 times u prime. Oops, do you see I forget my baby? Yeah, be careful. Don't forget our baby parentheses. They're super important. Okay. So we continue to copy it. Here, what is the derivative of 4e to the 3x? 3 times 4 is 12. 12e to the 3x, right? And what is the derivative of secant? Wow, that is secant u, tangent u times u prime. Derivative of 7x is 7, right? And then all over 4e to the 3x plus secant 7x squared. Okay, so next we're gonna continue. Okay, so what is secant of 1 minus e to the x? Well, here we have another chain rule with, this is our new u. Our new u here, right? Okay, so let's continue. So we have 1/2 secant 1 minus e to the x. Okay, questions. Can I combine the minus 1/2 and the minus 1 together to become 1/2 here? No, this is secant. It's not like 1 over secant, so we cannot combine. And then here, derivative of secant. Do you remember? 1 over x. So u is 1 minus e to the x. Okay, and then square root of u squared. U squared is 1 minus e to the x squared minus 1. Okay. And then times u prime. Yeah, it's quite long, right? Derivative of secant of u is 1 over u, and then square root of u squared minus 1, and then chain rule, you multiply by u prime at the end. And then we have 4 e to the 3x plus secant 7x minus square root of secant 1 minus e to the x. And then here we have 12 e to the 3x plus 7 secant 7x tangent, oops, what did I do? Okay, tangent 7x. Okay, all over Okay, I want to draw. Okay, so all over 4e to the 3x plus secant 7x squared. Right? Almost done, because we have one prime there, so we need to get rid of all the prime. Okay, let's copy one more step. Yeah, even though it looks like a big, long, complicated problems, but each step we only do one thing. Okay, so here the numerator derivative of 1 minus e to the x is negative e to the x. Or you can put a parenthesis here to indicate, okay, we don't subtract, we multiply, right? So 1 minus e to the x square root 1 minus e to the x squared minus 1. And then we have 4e to the 3x plus secant 7x minus square root. Our secant 1 minus e to the x. 12e to the 3x plus 7 secant 7x tangent 7x. Okay, all over 4e to the 3x plus secant 7x squared. Whew, okay, that finished the problem. Alright. Okay. Let's continue. Derivative of inverse function. Okay. So this theorem is quite useful because sometimes it's hard, given a function, it's hard to solve the inverse function and express it in a very nice formula. Okay, then we can use this theorem. So what is the theorem about? Let f be a differentiable function and suppose f has the inverse on the interval I if x0 is a point of the interval I at which the function f is differentiable, and let's say the derivative is not 0. And suppose the y0 is the y value of the points on the graph of the function. Okay, and then the derivative of the inverse function at y0 is 1 over the derivative of f at x0. Oh, a lot of math symbol. Okay, what does that mean? Maybe it's good to draw a picture. Okay, so let me draw some. Oh, okay. I gotta draw a straight line. Okay. Okay, good enough. Okay, so let's say this is the, and we also, let's draw a function. Okay, let's draw a function. Maybe like that. Okay, let's draw this function f. Okay, and then what is the inverse function? Okay, let's also suppose this point is x0 and this point be y0 and this point is x0, y0. Okay, so what is the inverse function? Okay, we know in order to draw the inverse function, we have the line y equals x, and we flip it over, right? So this point corresponds to this point. This point corresponds to this point. So it looks like that, right? Good enough. Okay, so you can see this point, it corresponds to this point. So what does inverse function do? It's like switch the x and y. So this point is y0, x0. So it means here is y0, here is x0. Okay, now let's look at the slope at those 2 points. So here, the tangent line, okay, the line tangent to the curve looks like that, right? This is a tangent line. And what is the slope? Let's say here the slope m of let's say m of f. Okay, m of f. Okay, so that is the derivative of f evaluate at the x value is x0. Okay, how about at this point y0 x0. Oops. Okay. Alright. It's very sensitive. Okay. Alright, so enter. Okay. Alright. And then let's look at this one. We have the tangent line. And what is the tangent line? Let's say this is the slope of inverse function f. So this is the derivative of the inverse function. Okay, evaluate at the x value is actually y0. Okay, now let's see. What is this guy? We know slope is change of y over change of x, right? But let's look at the inverse function because we're switching the x and y. So here we actually get change of x over change of y. Yes, because x and y switch. So what's the relationship between them? They are reciprocal of each other, right? Yes. So that's why we have f, the slope of f at the points x0, y0 times inverse function of f is 1. They're reciprocal. So that's why this is f prime at x0 times inverse function prime at y0 equals to 1. So that is why the derivative of the inverse function evaluate at y0 equals 1 over f prime at x0. Okay, so this is reciprocal. Do you remember we have something similar like that using reciprocal, but not exactly reciprocal? Remember that, I'm talking about some concepts that are similar, but not the same. So you can like relate those concepts and compare and try not to confuse. Okay? So remember before we talk about if we have m tangent, what is the slope of m normal? Okay, m tangent is the slope of the tangent line. M normal is the slope of normal line. Okay, what is m normal? Negative reciprocal. Okay, so there is negative reciprocal, but for the derivative of the inverse function, it's just reciprocal. There's no negative. Okay, so be careful with those two concepts. Don't get confused. Cheers. Let me draw a smiley face. Cheers. Okay. Alright, so that is the theorem. Okay, so how do we use this theorem? Okay, so let's look at example. Alright, so example 3, this is the function, okay? And let me get back. Okay, so here, this is the function y equals x to the fifth plus x plus 2, right? We want to find the derivative of the inverse function at 4. Okay, maybe you want to say, okay, can we find the formula of the inverse function and then we differentiate the inverse function? Well, but the problem is, how can you solve for x in terms of y? Well, in this case, it's hard. It's hard to solve for x, right? There's a fifth power and there's x here. It's hard to solve for x. So we cannot get explicit formula of the inverse function. But it's okay. We have the theorem of the derivative of the inverse function. We can use that. Okay. So first of all, here, remember the picture. We have x0, y0. This is on the f. And we have y0, x0. That is on the inverse function. Okay? And the formula is talking about, the slope of the tangent line at y0 is the reciprocal of the slope of f at 0. Okay, the slope of the tangent line of f at x0. Okay, so here, what is the 4? Well, the 4 is actually y0. So the first step, okay, we can see 4 is actually y0. Okay, but I would say the first step is better to find the derivative first. Okay, what is the derivative of f? Yes, 5x to the 4 plus the derivative of x is 1. Okay, so the first step is finding the derivative. Do you remember we have math recipe sheets? So you can copy the steps on your math recipe sheet. Okay? So every time when we see a type of problem and you can summarize the steps, it's good to write it down on your recipe sheet. Okay? So this is the first step to find f prime. So second step is identifying x0 and y0. So here y0 is 4. How do we find x0? Do you remember what's y0? Y0 is f of x0. So which means you plug in x0 into the original function. Wow, then you might say, wow, this is degree 5 polynomials. We don't know how to solve it. You're right. We in general, to solve polynomial equations, you need like rational root theorem, etc. But here I can tell you, the numbers usually are designed very easily. You can find it right away. So you can plug in some numbers. You can plug in, how about x0 is 0? Would 0 work? 0 plus 0 plus 2 is 2, so 0 doesn't work. And then try 1, right? So 1 to the 5th plus 1 plus 2 is, what is that? 4. So 1 worked. So when I ask you this type of problems, I will ask you the numbers are easy enough that you can like plug in and solve it. So you don't need to like solve a polynomial equations in general. The numbers should be easy enough that you can try some values. Try 0, try 1, try 2, try -1, try -2, and you can find it easily. Okay? So x0 is 1. Good. And then by the theorem, we get derivative of the inverse function f4 is the reciprocal of the derivative of f when we plug in x0 is 1. Okay. So that is 5. X to the 4, we plug in 1 in it. So 1 to the 4 plus 1. 1 to the 4 is 1. So 5 plus 1 is 6. So the answer is 1 over 6. Alright. So for the next example, I hope that you can pause. Oops. What did I do? Okay. Alright, I don't know. Okay. Oh, I know. Okay, I can go back. Okay. I really don't know how to move it back. Oh, okay. So here I am. Alright. Sorry, I'm still new to this software. Sometimes it's so sensitive. Okay. So for example 4, I hope that you can pause the video and try it by yourself first. Okay, after you're done, then you can play the video and then you can check the answers with me. Okay, all right, are you done? Good, let's check our answer together. So what is the first step? Do you remember? So when I ask you questions, I really hope that you can answer my questions when you like hear my questions, because it makes me feel that you're with me. Okay. All right. So first step, we find the derivative. The derivative of x squared is 2x. The derivative of square root of x. What is the square root of x? Well, this is like x to the 1/2, right? Derivative of x to the 1/2 is 1/2 x to the minus 1/2. And then derivative of 1 is 0. Okay? So that is the first step. We find the derivative. Okay. The second step is identify my x0 and y0. Okay, let's read the problem. Find the slope of the curve f inverse at the points 3, 1. Okay, you might ask 3, 1, which one is x0, which one is y0? Okay, it's the points is on the inverse function. So then this guy should be y0, this guy should be x0. Or you can think of this way. Well, y0 is f of x0. So if you plug in y is 3 and you plug in x is 1, do you have them equal? Let's see, f of 1 is what? 1 squared plus square root of 1 plus 1. Is that equal to 3? Yeah, so then we know x0 is 1 and y0 is 3. Good. So then the third steps. The slope of the inverse function at 3 is the reciprocal of the derivative of the function at 1. Okay, and that is 2 times 1 is 2 plus 1/2. 1 to the negative 1/2 is still 1. 1 to the whatever power is 1. Okay, so that is 2. What is 2? 2 is like 4 over 2. 4 over 2 plus 1 is 5 over 2. So then that we get 2 over 5. So that is the slope of the curve of the inverse function at the points 3, 1. Okay, so you might have many questions, then please email me or ask me during the online office hours. Okay, so always take notes when you're reading the videos. You can copy down the notes and then put question mark and then write down your questions and then you can ask me later. Okay, so we have one more practice. Find the tangent line equation of the graph at the points 1 and pi over 3. Remember how to find the tangent line? First step, we find the derivative. Prime. Yeah? What is the derivative of secant? So this is like chain rule. This is u. Derivative of secant is u times square root of u squared. Don't forget your baby. Minus 1 times u prime. Right? What is u prime? Well, that is 2, right? So 2x squared is actually 4x squared minus 1. Okay, so that is the derivative. Oh, you can see that 2 cancel. So we have 1 over x square root of 4x squared minus 1. Okay, that is the first step. Second step. We can find the slope of m tangent is the derivative evaluate at what is the x value. So this is x, this is f of x. X value is at 1. Okay, and then we can see we plug in 1, we have square root 1 here. 4 times 1 is 4 minus 1, that is 1 over root 3, right? Okay, so what is the tangent line equation? Right, point slope form. What is point slope form? What is the slope? Yeah, m tangent. What is the point? Right, we have the points. So we have y minus the y coordinates of the points, which is pi over 3 equals to the slope 1 over square root of 3. And then we have x minus x coordinates of the points. 1. y minus pi over 3 equals to 1 over square root of 3x minus 1 over square root of 3. And then y equals to 1 over square root of x minus 1 over square root of 3 plus pi over 3. So this is the tangent line. Okay. What happens if I ask you to find the normal line? Okay, how do you find the normal line? What is m normal? Is that reciprocal or negative reciprocal? Yes, negative reciprocal. So it's minus square root of 3, and then still point slope form, y minus the y coordinate of the point equals to the slope, x minus the x coordinate of the point. So y minus pi over 3 equals to negative root of 3x, and then, oops, it became positive square root of 3. So y is negative square root of 3 plus square root of 3 plus pi over 3. So this guy is the normal line. Alright. Okay, so we have finished this session. So don't forget that you can always print screen and ask me questions. Alright, see you. Have a good day.